both students that are by the light switches are not here today. Okay. Interest of time, I'm just gonna show you what the answers are. Again, if it's one mistake, we'll say you get 1 out of 2. If it's more than one wrong entry, it's a 0. Okay. So basically, it's compounded monthly, but there are weekly, right? Every week payments are being made. So this is 52. You want to have a goal of, your goal is to have 25,000, right? And notice here there are payments being made, but there's also an initial amount that is deposited. Interest rate, and it's over a 5-year stretch. So 5 times 52, right, gives you 260. So you will need to deposit, or Leanne would have to deposit $70.96 per week to make this goal happen, for that to happen, right? So 2 marks there. How much interest did she earn in 5 years? And here's where, because of rounding, you may have slightly different answers. So if you use the sum of interest, you get this. If you use the formula, which is future value minus present value minus number of payments times the payment, you get this. So both of them are acceptable. It's just that TVM solver uses all decimals of that payment. When it calculates it, it uses all of those, and so it's a little bit different from time to time. How much will be in the account after 2 years? And so you just go balance, and then you go 2 times 56, right, to get the 13,358.82 cents. It will be a negative, which is expected, right? It's in the account at the bank. You don't have the money. The money is right now at the bank, so don't worry about the negatives when you're stating your final answer. It shouldn't alarm you either. Okay, so 1 mark for the interest, 1 mark, right? So just 1 mark for this part right here. So far we're out of 4. And then the bonus, we'll make this a bonus today. Okay, if you did this right, either by using the formula and just plugging in 3 for the years, remember, if it depreciates at 11% per year, remember when we had to, if it's a decreasing function, you go 1 minus the 11% per year to get 0.89 to the power of 3, you get this. Alternatively, if you just wanted to write it, make this your x, right? The number of years is your x, so you type this into y1, and then you go second trace 1, x is it would be 3 years, right? Which is time. You get the same answer either way. So I'd say if you got this number here, we'll give you +2. If you came up with the right formula, but you just didn't get to the final, I'll give you +1. Okay, but it has to be exactly like this. If you put 11 in here, no dice, okay? Yeah. And on backside, the rate of return. What are we at? Sorry, let's do the bottom of this page real quick. So that would be 2 and 2, that's 4. So 4 marks are, and possibly 6 out of 4 if you got the bonus, right? So we'll make this 4 at the bottom here. And just add it up and see what you got. The back side. All right, the portfolio grows from here to here, right? So this is what's the rate of return of the stock portfolio. So we're just dealing with the portfolio. So you subtract what you started, right? Or what you end up with minus what you started with over what you started with times 100. So you get 26.93%. And just 1 mark for that. And then the rate of return of the GIC is lower, right? Why is it still a good idea for Marina to have some of her investment in a GIC even though the rate of return is lower? So I would say this, never mind question 4 here, right? I changed that. I would say you either talk about the fact that it's a low risk investment and it's safer. You can talk about the fact that you're diversifying, right? Like having money in more than one account is still a good idea, even though it doesn't pay as much, but you diversify. I also talked about the fact that Marina is nearing retirement, right? It's good to have some of the money in low risk. We would actually advise most of it, right, in the financial world. So if you made any one of those comments, you do get the mark. You get a mark for mentioning any of the things that I just listed, right? So it's a low risk, that would be a mark. You diversify by doing that, that would be a mark. And just saying that giving her old age or nearing retirement is a good idea. Okay, so far it's 2 marks for that. And then talk about Jermaine back here. 2 ways of doing that. That's why it's so busy, right? So let's cover up one of them. So you could either do it this way, where you enter everything except for n, right? You solve for n, I then turn that into years. It's approximately 41 years that it will take. Add the 41 to her age, that put her at age 59, right? This amount of time in years. So yes, she'll be 59 by the time she meets her goal. So way before the 65, right? Alternatively, so I would give you 2 marks for calculating stuff on your TVM solver, and then 1 mark for justifying whether it is attainable or not attainable. Don't just say yes or no, right? Like expand on it. The next one here, I did it a different way. I went, okay, from 65 to 18 or 18 to 65, that would be 47 years worth of time. So I actually left future value empty and I figured out everything else. This is what I mean by start filling in stuff and solve for a thing, right? One of the variables, and see if that's going to help you answer. You do even surpass, right? You go past the 150 if you do it this way. So yes, you will have surpassed her goal by 47,948 and 36, right? So you're making a very concrete conclusion, not just saying yes or no, right? Either one of them gets you the 3 marks, okay? Either method gets you the 3 marks. That's why I didn't want to do the simple interest. I actually wanted something that's a bit more open-ended. Because you need to be able to navigate that, right? What do I do when there's apparently more information given than what I, right? Like there's more than what I need almost. But so you make one of them unknown, and then you figure it out from there. Okay, so what are we at then altogether? We're gonna add it to you. Most of you did it anyways on the back side. So we have 1, 2 plus the 3. So that would make this backside out of 5, right? The backside is out of 5 because of the question that I added. So that would be what? 5 and 4. 5 and 4 makes this out of 9. Potentially 11 out of 9, right? If you got the bonus. Okay, guys, name and last name, and then pass it forward so I can give this back to you. I want to give most of these back to you, so you have extra curveball examples. I'm falling asleep. This will put you out in no time, right? But I'm sort of joking, but at the same time, there's some good stuff in here that I will probably highlight a few things next week. So let's cut to the chase. Even these formulas right now, don't worry about them too much. We won't need them right at the beginning. 64. So let's go to that example right here. Trina's employer loaned, right? So there's a loan. We're talking loan 10,000 at a fixed rate of 6% compounded annually to pay for textbooks and tuition. The loan is repaid in a single payment at the end of the 5 years. How much will Trina need to pay her employer at maturity? Okay. How much did the loan cost her? What would you expect to happen to the cost of the loan if the interest was compounded monthly? Okay. So we're talking loans here. Okay. So it's going to be a little different. So let's do A here, NI, PV, PMT, future value, PY, CY. Okay. So what do we know? That this loan will take 5 years, but I will first start at the bottom. It'll be a compounding per year. This is the tricky part. Are there any payments being made here, like regular payments along the way? There's only a single payment being made at the end of the 5 years. So technically no payments. No payments here. Exclamation mark. There are no regular deposits mentioned. So we just transfer this over to there. No payments. That's why we just make the 1 and 1, right? When it's a loan, we want the future value to be 0, right? You want to pay it off. There are no payments, so that's 0. The present value is what? It's the loan you're getting, right? And for us, that's going to be positive 10,000. Because when you're taking a loan, the bank is giving you the money, right? So we put a plus there. The interest rate is 6%, and this is over 5 years times PY. This just stays 5, no big deal there, okay? So let's calculate that. I actually want to do one with payments yet. So 5, just fill that in. No big deal. How much will Trina need to pay her employer at the end of the 5 years? This is actually worded in an interesting way. You get the loan of 10,000. You want it to be 0 at the end. No, that's not it. This is a weird one where there's no regular payments. We're gonna have to figure out the future value in this case, because you always end up paying them back more than what you got in the first place. You always do. So we're gonna solve for future value here. And so this is negative 13,382 26. And I will, when you do payments, this will be zero. I promise you that. But this is just a one lump sum. This is a very rare case where you don't have regular payments. Most of the loan questions that I'm going to give you will have a regular payment of some sort. Okay, so this is how much you will have to pay back. Okay, we solve for this. Okay, Trina will owe 13,382 and 26 cents at the end of the investment, at the end of the loan. 5-year loan. Okay. How much of the did it cost her? Okay. And we use total interest. That's what the total interest is attributed to. And you can simply subtract the two, right? So you go future value minus present value. Okay, so we go 13,382.26 minus the 10,000, no big deal. That's 3,382.26. This is what it will cost her, right? Like in this case, you're not earning interest, you are paying interest, right? So this is we call this the finance charge as well. Finance charge. Sorry. That's the same thing as interest when it comes to loans. C. What would you expect to happen to the cost of the loan if the interest was compounded monthly? Okay. Monthly compounding would result in more interest paid. And why is that, right? It's calculated 12 times instead of 1. It's charged 12 times per year instead of one time, okay, which is the annual compounding. So more compounding when it comes to loans are not good. When it comes to investments, higher compounding periods are usually better, okay? Greater compounding periods are usually better. Nice. I'll do one more here with payments, regular payments. So this one has no payments, and then example 2, we will have regular payments being made. So Lars borrowed 12 grand from the bank, 5% compounded monthly to buy a jet ski. Lars negotiated a regular loan payment. There's loan payments of $350 at the end of each month until it's paid off. How long will it take to pay off this loan? Okay. So for A, we'll just go ahead and figure this out. Okay, PV, PMT. For okay. And so compounded monthly, we're going to make monthly payments, happens to jive, right? Future value, we want it to be 0. We're making payments, and those payments are going to the bank. So this would be 350 negative. The 12,000 that we're getting is going to be positive, right? Positive 12 grand. You're getting the loan. You're giving this to the bank, right? So there should be a difference in sign. Your interest rate is 5%. We want to find out how long, and we know that the time is in N, right? We need N to figure that out. So here we go. 12 and 12 for the bottom, 0 for future value, negative 350, 12,000, 5, and we're going to solve for N. And let's write that down to 4 decimals, I would suggest. So 37.0732. We solve for it. So time would be 370732. Do we know what this would be in this case? Years times 12, that would be months, right? Already as is. So you can actually say months, right? Approximately 37 months. Or if you want a time in years, you would just go 37.07 ... divided by 12. So just over 3 years, right? So we could say months or years. It's up to you how you didn't specify. What's the balance owing after 1 year? Yeah, you use balance. And it's 1 year, correct? So it's 1 year times PY. Right, so this would be 1 times 12, which is 12. So let's figure out how much you would owe still on your loan after 12 months. So we go apps, finance. I'm going to go to balance, 12. So you will still owe 8,316.34. Okay, so this is for question B. What would be the balance owing on the final payment? This is tricky. Do I want to do that? I didn't write this particular question. That's why I'm a little bit rusty. But I'm thinking there are about 37 payments. Actually, in this case, the bank would say there's still another payment, correct? It takes you 37 payments and then a small payment one more time to finish off the loan. So this is actually going to be, we're going to go balance 37 to go off of that one. Oh, okay, sorry guys. You may go. Can you do the rest of, there's a question here and 2 on the back. That's all I want you to do for homework. Okay, I'm going to post the key.